Welcome to our ESA special program about Euclid. I'm Sandra Benitez, and we are here today at the European Space Agency at its Space Astronomy Center in the outskirts of Madrid. Today, we will discover the latest results from our fabulous Euclid Space Telescope that is designed to understand better the nature of the universe, especially dark matter and dark energy. Euclid is an European mission built and operated by ESA with contributions from NASA, and it was launched 1 year ago in July 2023. The Euclid Consortium, consisting of more than 2,000 scientists from 300 institutions in 15 European countries, the US, Canada, and Japan, provided the scientific instruments and scientific data analysis. We are very excited to be here with all of you. But before we start, a word of introduction by ESA's Director General, Joseph Asbacher.
Welcome everyone to this exciting program where we will show stunning, never-before-seen images from space that reveal more about the structure of our universe. Euclid, launched in July last year, is ESA's latest mission dedicated to mapping the cosmos by observing billions of galaxies across space and time. It will reveal more about the most mysterious stuff around us, dark matter and dark energy. These make up 95% of space, but no one fully understands what they are. Euclid shows star-forming regions in unprecedented detail, uncovering 300,000 new objects in one shot, including free-floating planets that are 4 times the mass of Jupiter. During its mission, Euclid will help us to better understand our universe, what it is made of, and how it has expanded and evolved over cosmic history. Euclid demonstrates the unique expertise of ESA. These images are the result of many years of hard work from scientists and engineers throughout Europe and from members of the Euclid Scientific Consortium around the world. Let's watch now as we gain a tantalizing glimpse into the nature of the universe and the very foundations of our cosmos.
And here with us today, we have a very special guest, Professor Carol Mundell, ESA Science Director and Head of the European Space Astronomy Center in Madrid. Thank you, Professor Mundell, for being here with us.
It's a real pleasure to join you, Sandra, on this special day.
Professor Mundell, what can you tell us about this incredible mission?
So the Euclid mission is our dark detective, and this is an incredible mission that we launched last year. And the big question that it wants to answer is what's the 95% of the universe that we don't understand? We want to understand the physics of dark matter, the nature of dark energy, and all of the stuff in the universe that actually is not the normal matter that makes stars and galaxies and people. And so it's a really exciting mission. It's phenomenal in the technology because we have an incredible reach, very big field of view, very sensitive detectors, and exquisite crystal clear vision. So pulling all of those together with its autonomous survey capability and the big international collaboration that we've pulled together to do the science makes it an iconic and unique world-leading cosmology mission.
Thank you, Professor Mundell. And what is the connection between Euclid up to space, 1.5 million kilometers away, and ESAC here in Spain?
So what's really special about ESAC, as you said, it's the European Space Astronomy Center. So this really is the home of science for ESA and for our 22 member states. ESAC represents ESA in Spain, and we have a very strong and close collaboration with the Kingdom of Spain, who kindly host us here on this special site. And although we call this the home of science, it's where we have our science operations centers and where we will actually pull all of the final data for Euclid together in our wonderful archives. We also have this digital library of the universe. So all of our science missions, be they planetary, be they solar, be they galactic, or be they cosmological, all of the data end up here, worked on by our experts at ESA, supporting our member states and their scientists. And not only do we have the home of science here, but we have a very strong educational program inspiring the next generation through these big iconic cosmic questions at the forefront of technology. And last but not least, not only do we have science on the site, but it's my privilege as head of establishment to host directorates from across the agency. So, for example, our colleagues from navigation who lead on the Galileo satellites, our colleagues from Earth observation who look down on the Earth and help us to understand the science of our own home planet, how to protect it and keep it safe, but also to put that planet into the context of the wider understanding of planets in the rest of the cosmos that we study in our science program.
Thank you, Professor Mundell. We are now going to unveil the new 5 pictures taken by the Euclid Space Telescope together with the scientists using the Euclid data. Professor Mundell, what can you tell us about the unveil of today?
So today is a very special day, Sandra. So these are the first time the world will have seen these incredible images. These images were taken in our early release test campaign, and what we're actually doing today is bringing the scientists together to explain the fundamental research that these images have enabled. And going through them, you'll be able to see the power of the Euclid mission, not only to answer that fundamental cosmology question about dark energy and dark matter, but also to understand what else makes up the universe, from galaxies to stars, right down to Jovian-sized planets. So it's a very powerful mission, and I think you'll get a flavour of that today with the first sight the world has ever had of these new images.
And you wanted to comment on a particular image today that is very special.
I did. I wanted just to show the very first image that actually our Director General Joseph Aschbacher will have released in a sneak peek to ministers in Brussels today. And it's our great privilege to be able to show this incredible galaxy cluster. And the reason that this is special is because the scientists are using what they can see in the light to try to trace what we cannot see in the dark. So we will hear more from our scientists later on explaining how exactly they do this. But this actually gives me goosebumps when I think about the power of Euclid to really unveil the hidden cosmos.
Thank you, Professor Mundell, for being here with us today.
Thank you.
And we are now going to unveil the rest of the images. We are now ready to discover the first Euclid image, Messier 78. And for that, we have here with us today Dr. Marusha Gerial and Jerry Chan from the Institute of Astrophysics of the Canary Islands. Welcome, Marusha and Jerry.
Thank you.
Let's first discover the image and we will come back to you in 1 second. Marusha, what can we see in this picture?
Look at this stunning image of vibrant stellar nursery. This is Messier 78. It's enveloped in hydrogen gas that's being illuminated by very hot and massive stars that recently formed in the core of this cluster. But we also see dark filaments of interstellar dust. This region is located at about 1,300 light years away, which is pretty close in astronomical sense. It's actually in the solar neighborhood.
And how is this view unique?
This image is unprecedented because this is the first such image of such width, depth, and sharpness. And such large field of view actually enables us for the first time to study objects of very low mass to such details and in uniform manner. And this is pretty unique because this is the first time we can do this, and it hasn't been ever possible before.
Jerry, why is Euclid the only space telescope capable of capturing this kind of view?
Euclid is the only wide-field space survey telescope that's covering the near-infrared wavelength. And the near-infrared light can penetrate dense dust and gases. Euclid near-infrared camera is so sensitive that has already unveiled the hidden regions of star formation for the first time. And with one shot, Euclid has uncovered 500,000 of objects, including galaxies and stars.
Marusha, what can we learn scientifically from this image?
In images like this from Euclid, we can study the number of newly formed stars, but also the number of objects that are less massive than stars. They're called brown dwarfs. And we're interested to see how they form and how they evolve through time. but also some of them are born as twins, which is especially interesting because they can tell us much more. They can give us much more information about their evolution and their properties. And what's the most exciting parts are objects that are, some of them are even a few Jupiter masses. They're called free-floating planets or rogue planets, and this is the most interesting part of this image.
So Jerry, can you tell us a bit about the connection between dark matter and what can we learn from it?
Dark matter, as we all know, is so mysterious and is invisible, but so far. Brown dwarfs and planetary mass objects are actually candidates for this missing mass. However, the individual object has so little mass that we have to find significant number of them to support this idea. So far, even in the solar vicinity, we still believe that we only found the tip of the iceberg. We have to find the slightest object as much as possible and as far away as possible to characterize this population. As Marusa said, Euclid will help us to make one step further.
Let's go on with our second picture from the Euclid spacecraft, NGC 6744. To comment on it, we have with us Dr. Francesca Annibali from INAF Astrophysics and Space Observatory in Bologna. Welcome, Francesca.
Hello.
Let's enjoy the view and we will come back to you in a few seconds. Francesca, what can we observe in this picture?
So here Euclid imaged NGC 6744, which is one of the largest spiral galaxies beyond our local patch of space. And this is an example of the typical galaxy that's forming stars in the nearby universe. And what is amazing about Euclid is not only the possibility to image in just one shot the entire galaxy with its beautiful spiral structure, but also to reveal the finest details on small scales.
What do you mean by a small scale? What kind of detail are we talking about?
So you can see here, we can even count individual stars and reveal the distribution of dust. We see all these feather-like dust lanes coming out from the spiral arms like spurs. So we really have a detailed distribution of dust and stars here in this galaxy.
And we can also see newly born stars with unprecedented detail, right?
Yes, and while it is quite common to have a detailed view of small portions of star-forming regions, it is quite rare to have such a detailed view for a whole galaxy, and so detailed view for all the star-forming regions that are around it. And consider that forming stars is the main way through which galaxies grow and evolve. So this kind of studies can really help us understand why the universe looks the way it is today.
So what can we learn from the scientific point of view with these images?
So from this kind of data set, we can understand the physics of spiral structure and the connection to star formation, which is something that is not yet fully understood despite several studies in the last decades. And furthermore, we can also hunt for new dwarf galaxies around this giant spiral. And indeed, we discovered a new one just right there. And this discovery was quite unexpected because these galaxies had been studied a lot in the past, but this showed really the high potential and power of Euclid in such kind of studies. And we really, in the future, we will be able to study thousands of nearby galaxies in such high detail, and we really expect new exciting discoveries to be done.
Thank you so much, Francesca, for this insight on the spiral galaxy NGC 6744.
Thank you so much.
We are now going to discover picture number 3, Dorado Galaxy Group, with Dr. Karina Vogel and Dr. Taimur Seifolahi from Strasbourg Observatory. Welcome to our